Hey, how's everyone? Hope you are all doing well, doing fine, surviving the pandemic. It is day 3 of Money and Banking. Time flies when you're just sitting around in your house doing the same thing day after day. So anyway, yeah. So what are we doing today? So today we're talking about Chapter 4 in Michigan, which is about yields and interest rates, right? So uh, Chapter 4 is really the first of 3 chapters and 3 days in which we talk about bonds and bond markets, right? So we're going to talk about how bonds work, how bonds are priced, and we're going to talk about how the bond market works and the impact of bonds on interest rates and uh, financial system in general and on the macro economy. So that would be really what we talk about the next 3 days. And so here today in Chapter 4, we're going to be talking about yields. And yields really have to do with, I would say, the mechanics of pricing bonds, right? How exactly are bonds priced, and how does their price relate to the interest rate on a bond, and then how does that interest rate relate to the yield? Okay, so um, let me back up here and just say that today we're going to focus on trying to talk about 4 different types of credit instruments, right? We're going to talk about first a simple loan, right? A simple loan. This would just be kind of loan you go into the bank and you borrow some money and you pay that money back with interest. And we're going to talk about a simple loan just to kind of get some basics about how interest rates are related to the price of borrowing. Then we're going to talk a little bit about mortgages, right? Mortgages are another form of lending. The thing about mortgages is you pay a fixed payment every single period, right? So for instance, if you get a mortgage, you might pay $1,100 on that mortgage every month, and you pay that until the end of the mortgage. So it's a 15-year mortgage. Every month you'd pay $1,100. And at the end of those 15 years, boom, that's it, right? You've not only paid your interest, but you've also paid back the principal in each one of those payments. After we understand those 2 credit instruments, we're going to talk about coupon bonds. Coupon bonds are the kind of bonds that corporate bonds are typically structured around. A coupon bond has a fixed face value. It has a coupon rate, meaning a stated interest rate. However, the price can sell at more or less than the face value, right? And so we're going to talk about how you price a coupon bond. And then we're going to talk about a discount bond. And a discount bond is how T-bills are priced, right? T-bills are short-term government bonds. Discount bonds have no interest payments. They just simply have a price that is usually less than face value. So that difference between the price and face value is essentially the return that you get on the bond. And so we'll talk about how you price these things. For each of these instruments, we're going to talk about how the interest rate is related to the price, but that is different than the yield, right? And when we say yield, we're talking about the true return from holding an asset. And so the big theme in this chapter is that a bond might have a stated interest rate, but what's the yield or the true return you get from holding that bond? It can be bigger or less than the interest rate, right? The interest rate does not tell you the true yield of holding a bond or the true return on holding a bond. And why is that? As we're going to see, because the price of a bond can differ from its face value. So when you buy a bond, there's really 2 ways that you can earn a return on it. One way is through the interest rate, but the other way is by paying more or less than the face value. And so as a result, yield is not always going to be the same thing as an interest rate. Okay, before we get into talking about these 4 credit market instruments, though, let's go back and review here a little bit about present value and future value. This is something that you all should have been exposed to in financial accounting and maybe some of your other econ and business classes, but let's just kind of do a quick review here of the fundamentals of present value and future value. And the key when talking about present value and future value is that $1 today is worth more than $1 tomorrow, right? So money is time, right? This is a fundamental financial fact that you prefer to have $1 today as opposed to $1 tomorrow. So if we work through a simple example here, let's suppose that the interest rate is 10%. If you put that money in the bank, what should you have a year from now? Well, if you put $100 in the bank, what should you have a year from now? If you have a 10% interest rate, you should have $110. In 2 years, what should you have? Well, that $110 will itself get a return of 10%. And so you should have $121, or 100 times 1 plus 0.1 squared. In 3 years, that $121 that you have at the end of the second year should also get an interest rate of 10%, meaning that you should have $133 at the end of 3 years. If we generalize this to n years then, what's the future value of $100? It's 100 times 1 plus the interest rate taken to the nth power, where n is the number of periods, right? So this is just basically the compounding of money, right? If you put money in a bank, it compounds over time. At what rate does it compound? 1 plus I to the nth power. If we turn this around, then we can also work back. If you tell me what the future value of something is, I can turn it around and tell you what it's worth today. So just like the future value of $100 is $133, right? So $100 today is worth $133 in the future, or $133 in the future is worth $100 today if the interest rate is 10%. The key to all of this is you can't compare $1 today with $1 tomorrow, right? That is financial malfeasance, right? That's financial incompetence. If you just add up money over time and think that it's all worth the same, you're understanding the basic principle of finance, right? So of course, all the time people lie to you by making this mistake, by adding up money over time and just acting like $1 20 years from now is the same as $1 today, right? Here's just one example that you see in the news all the time. What happens if you win $20 million in the lottery? Do you really win $20 million? And the answer, of course, is no, because if you look at the fine print of that lottery, you'll see that almost always it's paid out over 20 years. So if you use an interest rate of 10%, right, really $20 million paid out over 20 years, right? So basically $1 million a year for 20 years. The present value of that is only about $9.4 million. You lose half the true value of that because of compounding in present value. And so, all the time, people try to lie to you with this. Sports stars and taking deferred money, right? There's those of you who are sports fans or baseball fans, you might remember the case of Bobby Bonilla, who has played for the Mets in the 1980s and 1990s. And he wanted to have the richest contract in baseball. And so he basically had his contract pay out like over 25 years. And so, yeah, when you add up all those dollars over 25 years, it was the biggest contract in baseball. But of course, he's been retired for like 15 years and he's still getting paid. The dollars he's getting today are worth a lot less than the dollars he got paid back in 1990. And so you can't compare money over time. You have to account for present value and future value. Which then leads us to the yield to maturity, right? This is going to be our definition of yield, how we calculate the true return on holding an asset. The yield to maturity is the true interest rate that equates the current price of an asset with the present value of future payments. All right, let me say that again. The yield to maturity is the true interest rate that equates the current price of an asset with the present value of future payments, right? So when you calculate the true return on a bond or any financial asset, you're trying to figure out the interest rate that makes today's price equal to the present value of future payments, okay? So the easiest way to understand yield to maturity is to do some examples, right? And I think as we do some examples, you might want to come back and continue to look at this definition. And as I hope that as we do a couple of examples, you'll begin to understand what we mean by the true interest rate that equates the current price of an asset with the present value of future payments. So let's begin here with the simplest kind of asset, a simple loan, okay? So a simple loan is I borrow $100 today and I pay $110 a year from now. What is the yield to maturity? And so here, the present value is $100. The cash flow in 1 year, in other words, the future value, is $110. The number of years is 1. And so using our present value, future value formula, if we set the present value today of $100, it's equal to the future value of 110 divided by 1 plus I to the n. Because n is equal to 1, this is pretty simple. Here we see that the interest rate is just 10%. And that should not be surprising to you because we just worked through this example in a couple of minutes ago. So interestingly enough, for a simple loan, the simple interest rate is just the same as the yield to maturity, right? So the yield to maturity is the interest rate for a simple loan. There is no difference here between the yield to maturity and an interest rate. That's not going to be the case, though, as we move to more complicated kind of financial assets. So let's talk about asset number 2 here, a fixed payment loan. A fixed payment loan is a mortgage, okay? It's a mortgage. So most of you have probably not entered into a mortgage, but I think I described here a moment ago how a mortgage works. Usually a mortgage is 15 or 25 years, and what happens is you make a fixed payment every period from the beginning of the mortgage to the end of the mortgage, right? So every month you make the same amount of payment. Each one of those payments is in part interest, in part it's also covering your principal, okay? So here we have an example. What's the yield to maturity on a loan of $1,000 and for which you pay $126 a year for 25 years? How do we calculate that yield to maturity? Well, let's go back and think about our definition. The yield to maturity is the interest rate that equates the current price to the present value of future payments. What's the current price? $1,000. That's how much we borrow. What's the present value of future payments? I make a payment of $126 a year for 25 years. So make a payment of $126 in the first year, discount that by 1 plus I. Make a payment of $126 in the second year, discount that by 1 plus I squared, all the way out to the 25th year. Okay, this equation is the equation that I need to calculate the yield to maturity. Now, here's the difficult part, is that there's not a closed form solution to this problem. In other words, you can't really solve this algebraically. What you need to have is a financial calculator. And what a financial calculator does is it basically picks different values of I until it figures out which value of I works. And so you can't do this by hand. You need to have either a financial calculator or you need to have a program on your computer. For the homework number 1 that I'm going to assign to you at the end of today's lecture, I actually give you a link online that allows you to calculate the yield to maturity on a fixed payment loan. Okay, so I'll give you a link that will actually do the dirty work for you. But if you actually use that financial calculator, you'll find that the interest rate is 0.12 or 12%. That is the interest rate that equates, once again, the present value or the current price with the present value of future payments, okay? All right, now that we understand a simple loan and a fixed payment loan, let's begin to talk about bonds. And so we're going to call that an end of the first section of today's lecture. And we'll come back with section 2 where we talk about coupon bonds and discount bonds.